So hi guys, here I am teaching you how to create games, how to make games, and different type of things in what is game development. First of all, what is game development, and how it is different from game designing. So today I'll be teaching you that. So hi, I'm Nishit. I'm from Realscape Simulation, and today, welcome to the lecture. Welcome to the lecture of quarantine learning. So basically, what is a game development? See, a game development is nothing just a sequence of images or a sequence of different types of algorithms that we use for achieving something can be considered as a game. For example, I can give you like for if you press one of the buttons on your keyboard and it does something on your screen, so it can be anything. For example, you are typing. For example, you are using the word. It can be anything, but that is you are simulating something. So in that software, that is the world that you are using. But in the kind of simulation or in that kind of game, what it is that whenever we press any of the keys, for consider WASD, so those are the keys to actually move the character, or the different word is to transform their vectors. Basically, now you would be confused, what is vectors? Nothing. The vector is the position of the player, just that. So WASD is the player. So whenever we press W, there is an algorithm behind it that that happens. So behind that a normal thing happens, that a position of that vector increases. For example, if I press W, then the vector dot forward, so there is a function in that. So vector dot forward, in that the position of it increases, that it is called as incrementation. So now, first, before we go into all those mathematical stuff and stuff, first will be what we will see is what is video game development, first of all. So in C, the best way is to understand what is game development is to learn, is to understand what is a game, right? So for all of you who are watching this video would be playing a game. It can be any game. It can be a PUBG. It can be PUBG. It can be Candy Crush. It can be Ludo King. It can be many different games. Like many of you would be playing AAA games. AAA games is nothing, just a game that is very good enough that it is created by a whole team of 1,000 to 2,000 peoples. Understood? So what is a game? What is a game, right? So in a game, how do you create a game? First, the question is that we understood what is a game. Now, how do you create a game? See, there are many things in creating a game. You, first of all, for creating a game, you need an idea of a game, like how the game would be, or for example, how the things would be in that game, how you want that character to explore the environment in that game. Understood? So the first thing for creating a game is to develop an idea, or we consider as a concept for a game. Then you design the environment, then you program it. Basically, programming is giving the interaction to the character with the environment. Then we use a rendering procedure. Then we use some record, the music, and that's some UI and stuff. There's many things that come together to make a full-fledged game. Now there are many different things. It's like first we start into it, we would be thinking that yeah, I need to come into game development. What things I have to share, what things I have to see, look into that. How I can come into game development? No, that's not a thing. The main thing is, if you want to come into game development, you just need to be creative. You don't need to be like a high-fledged coder or high-fledged programmer, that it is like normally it's going through that you need to be a programmer, for example. The main thing for creating a game is idea. If you have that idea, then you can create anything. Now the main thing is, in the in game development programming is used, no doubt. The one should know what is the programming. Consider, like, programming is the base of anything. If you come under the game development, or because it is a game development, right? So development means writing something or coding something or programming something that actually interacts. So a coding part comes in it, but many people would be like, some of the people who are watching this video would be like, yeah, I don't have a coding experience, I don't have a coding profession, then what I should do? See, it's not that only actual hard coding is used in game development. There are many type of different softwares, or in the world of gaming industry, the softwares that we use, we call it game engines. So there are many game engines in that. There's not only coding is used, but also visual scripting is used. For example, you don't have to actually write a code or a function to do everything. The libraries and the function are already stored inside them, and you just have to explore that. But you should have a knowledge that what it is. So that's the thing. You don't have to be the professional full-fledged coder to do all those stuff. So basically, now we come into the, see, at this point there are two things in game development we consider. So there are two concepts. There's a parts of game development. First, there is game development. Second, that is game design. Okay, so now confusion, right? What is game development and what is game design? So the main thing about game development and game design is the game development looks into all those things that comes under programming, that comes under what we consider it, interaction and stuff. And versus the what is game design? Game design is just the environment design, that how the environment would look, how the texture would be looking. There are many things in that. Now what are the stages? Like, for example, obviously I just told you that you need an idea, then you do this, but what is the actual procedure of doing that? The main thing in this is you need to have a concept. If you have the idea that what your game would be, then you can do it. Now after that, what you do is you pitch your idea. Like, what is pitching, right? So there are two things in pitching. For example, when you pitch your idea to someone, like, you have an idea, right? You have noted out it on paper, you might be anywhere you have noted down. But second thing is pitching. Now you'd be saying, what is the thing in pitching in game development, right? But in game development, pitching is something that is main important. For example, after developing an idea, a game developer or any person who is creating a game goes to a person or a company or anything to pitch an idea. Now why to pitch an idea is because, for example, I have created a game. I'm not a concept of a game or a game idea. Now I might not be having that much finance to that produce that game, correct? So what I would be doing, I would be pitching this idea to some of my friends who are interested in this, or also in the same career in this, so they can help me out. Or second thing is, I can go to some of the investors, or in a commercial I can pitch it in a way so the the investor can invest in my game, so I can hire some people who can help me develop this idea into an actual game, right? So that is the main importance of pitching. Now what is concept? Like, you have an idea, you have a pitch, like you have already pitched it, you have got an investment, or might be possible you have got a friends to come along to help you in this. So after that, what is concept? The concept is the demos or the images, like a visual representation of the images. We can consider as images or the scenes, like how your game would be, how the UI would be, how the environment of the game would be. So that all the things comes under the concept, like how the character would look. If for example, it's a PUBG type of game, for example, the PUBG is a battle royale genre. So if that comes under that concept, so concept in that PUBG concept would be 2 to 3 different things. First, your character. Second, guns and stuff. Third, your this maps. Fourth, there would be a specific place or a specific area in your map that would be a very delusionish area. So you need to create that look or that intense feeling for that digital artist, or we consider it as a 3D artist, that he can understand it and he can actually create it in 3D. So that all those things come under the concept. Now, what is game design document? See, the game design document is nothing but it is actual gameplay. Like you'd be confused, like we directly into comes under the game design document. No, actually, the what is game design? Game design is just the basic prototyping of it. Like before creating any of the game or any of the simulation, we create a base of it. Why base of it? Because when we have created the one base of it, we can just copy it, we can just duplicate it to multiple players or different things. That's the reason game prototyping is important. For example, today we'll be learning space simulation, right? So for example, I need to revolve a planet around the sun. So for that I have to write a code. So I won't be writing the code for all of the planets. I'd be just prototyping it basically. I'll be writing the code for only for one planet, and then I'd be using that same code onto others planet, just using different types of what we consider it, different types of position vectors and just the placement difference and stuff. So that is all those things comes up prototyping. Then comes the production. Now what is production? The production is basically the design is the level design and stuff. After that comes in the level creation. That might be possible your game would be having 2 to 3 different levels. Like I'm talking about a small game. For example, if we consider Candy Crush, it's having more than 2 to 3000 levels. So all those levels have been created. So that level creation comes under that. Then programming comes, like like we are talking about Candy Crush, right? So in programming, we have to code it, or we have to program it that when 3 of the candies come together in a line, it bursts, or if 4 of them come in, you get a power up. So all those things, all those implementation we consider comes under programming, right? So there are different things in game development. There's not only programming but also designing. So for example, now at this point, me also personally, I have many friends who are into engineering field, right? So they would be like, let's explore the world of game development. So what they would be doing is they would be going into programming. Why? Because they have the engineering background. So they would already having the best programming knowledges. Like they would be using the Python, they would be using Java, PHP, Ruby, C#, C++. There are many different programming languages to create a game. So but it's not that only the programming field or the engineering background or the programming background people can only comes into programming. If you know sort of visual scripting, then also you can come under programming. But make sure that programming is mainly visual programming. Second thing, visual programming is mainly a base of programming. At some point, you might have created many of the games without the use of programming language. You just used the visual scripting, but at some point, at a point where you have stuck in that visual scripting that you can't do this thing, at that moment you have to go on to that hard coding programming using these languages. Now the main thing is this languages differ from engine to engine. So now as we are into game development, we won't be using the term software anymore. We would be using the terms engines, because for creating a game we need a game engine, right? So we would be using the term engines. So there are different types of engines that use different type of programming language. So in this tutorial today we would be learning Unity. So Unity uses C# language. Then another language is C++. Then C++. There's one more engine called as Unreal Engine. that uses C++. There's one more engine called as CryEngine that uses Python. There are one more engine known as Love 2D that uses Scala and JavaScript. So there are many different things, different programming languages. You can see there are many of the people who know how to develop websites, right, using CSS, HTML, JavaScript. So even also using that scripting languages, you can create a game. There's no limit to it, but you just need an idea what to do. Now basically, what does a game developer do? There's a main question, right? What are the field of it? You will be procedural. So in this today's lecture, I won't be going all the things the into game development, because there is a whole lot of PPTs and there are many stuff. There are many stuff into game development, that what comes under it, what experience you got, what are the resources. There are many things, many things. So that we would be covering in the next lectures. So now you'd be thinking that, okay, so what we'll do now? So okay, for example, we have talked about engines, right? We were talking about this programming languages. We were talking about engines. So in today's lecture, we would be using something called as Unity engine. Yeah, see, Unity game engine is a universal we consider it as a universal cross-platform game engine. It can create games for all types of consoles, mobile, Android devices, iOS devices, even for Linux, even for Mac OS. You can create games for all the operating system that is currently available, because that is a cross-platform and universal platform to create games. There are many type of AAA games, or we consider as a high games that is created in Unity. We have Flappy Birds, we have Crossy Road, Subway Surfers, then we have Temple Run. These are the basic that are phones game that has been created with Android. But does Unity is able to create high level AAA games? The answer is yes. You just see to it. So you see, there's a Inside, Ori, Mother, Wasteland, Rig 2. There are many games, many games that are created in Unity. There's a whole list of it. So you just go into the official Unity website. Now see, all those things happens. All those things. See, there are how many games they have created. There's a whole new, the Cuphead, Mount Valley 2, Rick and Morty, Inside, Ori the Blind for Hellstone, Cities, Skylines, and those are the official recognized game by the Unity team. There are many different high AAA games that is created in Unity. Now the main thing is how we can use Unity, right? How do you download it? Is it free? Is it paid? Right? The good thing about Unity is it is free of cost. Like only for personal users. Just bear with me, my internet is kind of slow. So see, what is Unity engine used for? It's used for games, it's for automotive transportation and manufacturing, film animation and cinematics, architecture, engineering and construction. So we'll be going into all of these topics in the further videos, but today we'll be focusing on games. So we'll be clicking on games. So see, these are all the tutorials that they have already given, right? But they are not basics, they are high level programming lectures. So today we'll be actually going into the basics of it. Well, go click on get started, and you see over here that if you are having this if you are using this business thing, business Unity, then you have to pay $40 annually and pro. But if you are using as individual, there are three things in this. In three things, there is student, there's a learn tools, workflows and use professional on the go. There's a sign up, there's a student of it, in which when you sign up on it, you would be asked for all the information that you would be carrying out. For example, your university, your ID card informations, and many all those things. But after that you would be provided with a student license for maybe a year of 2 to 3 years. But in the personal Unity user, it's free of cost, but it's a limit in that. It's free of cost until you make a revenue. Like for example, all of we create games differently. We have different type of concepts, right? So for example, I have created an Android game. In that Android game, I would be using ads, right? Every game has ads. There are different type of ads, right? So why they actually insert ads in the game? Basically for generating the revenue. That thing is called as monetization. So by using that monetization, or by selling your game, or any type of means, if you get a revenue more than 100k dollars, means 1 lakh dollars in the last 1 year, is actually less than that, you can use the personal edition. If not, then you if you have more than that, then you have to use this business. Like they have the different plans for it. So first what we will be doing is we will be downloading this Unity software. So go and click on get started. It will be like first time user and returning user. You guys would be clicking on start user. You will be like agree and download. So it will download a Unity hub setup. So I've already have this hub setup. So what I will do, I'll just go to my hub setup. So this is the things after you click on enter of the hub setup. You click on yes. It loads it behind. So this is the first screen when it appears. You click on I agree. You install it. I've already installed it, so I won't be installing it. And after installing it, you would be opening when the hub opens, it'll be open with this. So actually not this one. The hub would be open with something else. So you would be open with this this area. So you have to activate your license. So click on activate new license and click on Unity personal, and just select any of the things. If you are trying to create a professional game and you would be thinking that you would be starting something or less than that, you click on this company or organization, or else click on I don't use it in professional capacity, and then click on done. So after that, this activation process would go, and you would be noted out with this. So after this happens, all those things happens, you have to you also have to log in this. So after you click on, after all the stuff, you select where you want to install your Unity. So after you install it, you go to this part. It comes under this. Now there are many. You come inside this install part. So what is this install part? That these are the Unity engines that they have provided. So what do? You create a ad. You install one of your engines. See, you see this latest pre-release beta. See what the beta version of engines are. It's basically unstable version of engines, but they have many things that they would be putting it into the future releases of the engine. So they are also giving that as a beta. So all those things comes under the 2020 version. Now there are different things into that. There's Unity 2019 3.6. There's 18. Now you'll be seeing what is LTS. LTS is long time support. That this version of engine has having the long time support. If you occur any of the problem, you just go onto the Unity website. You just scroll down. You just contact them for FAQs and support and services, and just tell them that you have been in this issue. I'm talking about the Unity game engine issue. I'm not talking about your games issue, right? So click on next after that, and then your engine would be installed. After that, till that time your engine gets installed, I would suggest that you download the files from the description below that I have provided. You'd you'd be provided with all this stuff. In all this stuff, they are the uh, what we consider is sorry. There are these images. There are the images of the textures we consider. Second is of Earth, Mercury, Moon, and stuff. Then you have this different three scripts that I will be telling you what they are about, and one of the scripts we will be creating ourselves. There's a environment skybox. The one of it is this. This is panoramic skybox. Then second is six-sided. Now I'll be explaining what is six-sided and what is panoramic. We have this asteroid FBX for creating a asteroid belt. You see this? Yeah. And we have this model size comparison. So as of the Earth and Sun and different type of planets in solar system, each planet has a different ratio of their size, right? So this is the universal size that comes under the ratio, that what we have to do. So what we as we can't create sun this whole big, we'll be creating it as a small sun, but you will be following all these ratios in centimeters that we are having. So after you have installed your Unity engine, you just go to the add. So you go to new, you create a 3D project. In that, write your project name as solar system. Like it's why solar system, because we are your planet and stuff. You can even write anything. You can just write a space simulation. You create you insert a location into that, and then create. See, this Unity engine takes a bit of time to register, and it's telling me to update, so I'm not gonna mind that. So for using this Unity engine, you should know what is. See, this is the Unity engine that we are seeing at this point. So what is all this, right? So what we'll be doing is, first I'll be explaining you the interface of this Unity engine. So we start from the basics. So you see this file, edit, all those things you already know the stuff. This is a menu. These are the different type of selection types. You see, whenever you hover onto it, you can see what it is actually. This is for creating a pivot. Pivot is it'll be explaining you what is pivot and stuff. This is the play button. So after creating prototyping a game, you have to test it, right? So this is the for play and pause. In this scene you would be creating, or you'll be inserting all those stuff that we are gonna do it. This is the hierarchy scene. It shows that what all things are there in the scene right now. So you see there's a camera icon over there. So when we click on it, you see there's a main camera over here. When we click on this light, you see this is a light, that directional light over here. So all those things are there, right? So for example, and this is a project menu. In this we would be importing many of the stuff. You would like import new asset and then import. If anything we select onto the in this scene or in this hierarchy, we get the settings of it in this inspector panel. We change the settings of all those things in the inspector panel. We can change different type of lighting. This is the wall lighting that we are using, so we can change it. And after creating all those things, whenever you click on play, you don't directly play in this scene. You play according to the camera that we have placed. So in this game window is the main thing. We'll be seeing what this asset store would be, right? So Unity engine provides many things on their own in the pre-provided manner, that you can download those stuff. You can create many things over here. So that we have it. There's a curved UI stuff and the many things, because Unity engine is not just limited to basic game development. You can also do AR development. You can also do virtual reality development. There are many things into this, correct? So first what we would be doing is we would be creating, for creating anything, you just click on right click in the hierarchy, you go to a 3D object, you create a sphere. So for example, when I created a sphere, it went under some different location. So what do you do in this? You see this transform, right? So in this transform, you see this position. Just click on it, write 0 0 and 0. So what is 0 0 and 0? 0 0 is just the start, the center of a scene. You see, this is the center of a scene. And how this we would be looking this in the game view is like this. Now for example, when I change the direction of the line, see, normally when you select any object, you would be provided with this arrows and stuff. Like this is for movement, for adjusting the position of the object. But when you're in the object and when then you click E, then you can rotate the object. You see, I'm rotating the object. I'm just changing the different type of lights of it. And there is R. R is for scaling of the object. You can even do all those things from here, from the transform panel, but there are multiple ways to do it. For example, in this when we created a sphere, we just went to 3D object and create. But here also, when we go to the game object, 3D object, and from here also you can create a sphere. We'll be doing it both way. So I will create a sphere. See, it comes in some another way. So we'll do 0 0 0. We'll be pressing W. So now it's overlapping. The two objects are overlapping. So I'll just take it. Now first I told you that what's the idea, right? So you know, we already know what we are creating a space simulation. So for creating a space simulation, we would be needing all the planets, all the suns. So what we would be importing the asset. There are two ways of importing asset. We'll import new asset. Go locate your asset folder and then import it. Just click on it and import. This is the one way to import it. See, you see now the object has been imported. You can just view it from all sides from this inspector tab. Now the another way to import is just go to the content folder, click on planets, and even on Skyboxes, drag it and drop it into the Unity project folder. It takes time to import, and after it imports, what do we do is after it imports, it's over here, right? So you see this is a scene, right? You see this is the name of the scene, the sample scene. What we'll be doing, we will be saving this scene as space underscore simulation dot unity. It's the default package. In this is scene, we'll be saving under this. Save. It's here. Now for I have included three type of skyboxes as you want to use it. One is this one, actual Milky Way, that there is the another skybox is this one, up, down, and now you'd be thinking how we would be inserting in this skybox, right? So there's an easy way of doing it. You just click, you go inside the skybox, you're gonna right click on it, you go to create, you go to material. In this material you can just write Milky Way, and when you write it, you see there's a albedo maps and there are different type of maps, but you can't apply this map onto this sphere. Why? Because we want to apply this as a skybox, that it should be around the environment. So what we do, we go into the shaders, you click on it, you see there's a different option, and you see there's a skybox. In this skybox, what we are having is a cube map. So we click on it. and then we drag that cube map onto we click on it. First, what we do after importing all this stuff, we have to go to texture shape and we have to transform it into cube and then apply. Now it will look something like this, and then go to Milky Way and then drag and drop it. Now you have this different type of Milky Way, right? So you can just, what do? You just drag it and drop it into this sea. You see, now we have a good looking environment and a Milky Way. This is the one way of doing it, using a panorama image. The another way is using this six-sided images. You see the different type of images that we are seeing, back, down. So in this, what we do the same. We go to create material, but this time what we're doing in the skybox, we will be creating six-sided. You see, there's a front, back, left, right, up, down. So in this same thing, we'll be applying that. So you have the back, so we go to back and apply that. We have a down, front. See, as we are just placing it, you are seeing that here you are seeing the updates. Now we have front, so we'll be inserting front, then left, then we have right, then we have up. You see, we have already created a material. The same way what you do, if you want to use this, just use this, or just drag and drop this. You see, this changes whole look and feel of the scene when we insert it, right? This is the one way of, this is the way of we create a skybox. This is how you create a skybox. Okay, I'll be using the magnifier app a bit. Okay, I'll be using the zoom, don't worry. So now what we'd be doing is we'd be prototyping a thing. Now we have this sphere, right? So first what we'd be doing is we'll be creating a sun. This is a sun. We have this, we zoom on it. I'll just zoom it. We click on this, we create F2. F2 is just for renaming. We will be just renaming it as a sun. Then we have this small second object, that this is the first planet we consider, right? So we click on it, we just name it as Mercury. Now we have to we have to texture it, right? So we already have this all those scenes and stuff. We have this textures, right? We have this sun textures, we have the Mercury texture. So how do we apply on it? It's easy to apply on it. It's just click on this sun texture, just drag it and drop over the object, and you see it applies over the object. Now this is Mercury, right? So go to the Mercury and just drag and drop over it. and this, and when you do it, you see here in this material box the material is created already. Now you would be thinking how this material how we can create it instead of actually doing this. So what do? You just click, right click, you just create, you go to material. In this material, just click. Now I'll be creating material for earth. We just click earth, and when we click on it, on the right column, you see all those things are available over here. There's the information about the textures. So in this main maps, albedo is the color, metallic is the metallic look of, like is it metallic or not. There's many different things in this. There's a height map, there is an ambient occlusion, there's many things. Now what we'll be doing, we'll be click on this albedo circle map. Click on the albedo surface mark, and you see there it opens a texture file, like from where, well, all the images that we have in this project folder, that it's shown over here. So we can select it over here. This is the one way of doing it. We just select it and we just cancels it. So there is one, this was the one way of doing it. The another way was actually drag and drop and placing it into that small square. So after that we create an object, right? So in 3D object we go to sphere, we rename it as earth, right? We adjust its position to 0 0 0 and then drag it according to that. And then in this we have already created a material, right? Here we can see it. You can directly drag and drop over here without any issue, but I won't be doing that. I will be seeing a normal practical way of doing it. You go click on this object, you see this materials. In this default material is there. See, now you click on this small round icon. You won't be visible, like, let me. So click on this small default material. In this you can select that material, like we have created the material, right? So you can search it, EARTA. You see there's a material over here. So when I click over here, you see there's a the material has been applied. So this is the one way of applying the materials, and the another way. Now after this, what we'll be doing, we have our environment, maybe we have our planets, but we need these planets to revolve around the sun, right? So what do? We go to we create a script out of it. Basically we program it that this object rotates around this object. Okay, so what we'll be doing, we'll be right clicking it, we go to create, we go to C# script, and in this script we'll be writing the name of the script. It will be rotate, like it's rotating around the sun, so it will be rotate. We click on it, and when you click on it, double click on it actually, so you see this Visual Studio opens. What is this Visual Studio? This Visual Studio is basically a default programming IDE that we can write a code into it. Now what do we code into it, right? That's first thinking it. So we need to go to the basics, that how do we need to revolve around this. There are two different things. First, there should be a specific speed, because every planet has a different type of speeds. Every planet is a different radius, so we need to think of that. Second is we need to have a speed multiplier. Like, why speed multiplier? Because speed is calculated in the what we consider it is the basics of the radius and the speed. like dividing and using the mathematical function, we divide the speed and the radius, and we bring out the square root, and that way we create a speed. So all those, after all those functions have created a speed value, that speed value is actually going under the 0 degree, what we say, in the negative. Might be possible it won't be going into negative, but it won't be going more than 1. It might be in 0 point some value, but that is so slow that it might be feel that the no planets is revolving around the sun. So we have to multiply the speed around it according as the actual it is. So what do? We go over here in this code section. What do we, before the start, we declare some variables. Now what is this variable, what is this declaring, right? So for creating any of the game or any of the things inside it, we need to declare something. Like for example, if a player is moving from this place to another, we know that he would be using W key, right? So but the thing is, whenever he is moving, what should be the speed of it? You might have all played all the games in that when we press W, a player moves forward, but when we press shift and W together, a player moves faster. So we have to code that, we have to increase its speed, right? So for that we have to declare a variable that we have to multiply it by that number to actually speed up that. So what we'll be doing is, we'll be declaring over, there are many types of declaration. One is int is for integer. We have float to integer decimal point number. We have long is for declaring the integers more than what we can say, the more than 8 digits. Then there is double for declaring floats more than 8 digits. Then there are boolean. Bool or boolean is basically true or false. All those what we say, the variable declarations are over there. So what we'll be doing, we'll be creating a float. Why for example, now why float and why not int? See, basically speed, we'll be dividing it, we'll be multiplying it as per the radius. It might be possible there might be some sort of division or some sort of square root inside it. So we can't round off that figure, or else the speed of it would not be perfect as we want. So what we declare is, we declare it as a float, right? So in this float, we declare float speed. After declaring, you see there was a red mark over here, and now there's a red mark over here. Why? Because we have not ended that statement. If we don't end this, then we'll get an error. Then we'll create one more variable, that is float, and that's the radius. Now this radius, this radius would be taken from the object that we have placed the script onto. If the radius of the Jupiter would be something, 51 was for something, then this script will take that radius and use that radius as a calculation for it. Then what would be, we would be using a speed multiplier. We can just int speed multiply, and we'll just close it. Now for the main thing, see, when I create anything in this rotate section, see, when I create in this all the script section, I can't see anything. See, here it's compiling, right? So when I click on the script, I can see the script, but I can't see, I can't change the objects from the Unity editor. Why? Because those objects are not visible or not changeable inside the Unity editor. You have to go and code it, right? But what if you don't want to code it and you want to change it from the editor itself? So what do? Is just you go to the script itself, before the end you just write a declaration that is called as public. So when you write this public, so what does it do? It opens this int speed multiply for this editor enough to edit inside the editor. So now it's editing, and now you see magnifier. Okay. So see, this rotate script is over here, but when I apply this onto the Mercury, you see, you go inside Mercury, you can see this. There's a speed multiplier over here. If I just comment out this speed multiplier, see, double slash is the comment out. You see, it goes and compiles it, and you see the speed multiplier would be gone. Why? Because we have not declared it as a public. For example, if I've commented out, right, I'll just remove the public statement and just recompile it. You see, you can't see the speed multiplier. Why? Because it's not public over here. So when we click on public, we have the access to change it inside the Unity editor. You see, you can change it over here. We go to the script. In the script, in the void start, what we have to do first, right? So now like I have after initializing the speed, we also want that object to rotate around something. We don't want to rotate it anywhere or any place or anywhere, right? We want to rotate it around sun. So we need to have the sun inside the script, so that we have to call that object, right? So we do the same thing. What we do, we public it. Why? Because we can edit it inside the editor. Then we create a game object. It's all those codes that we are writing at this point is case sensitive. We create a game object. And what's the game object? What's the name of the game object that we write? It's like center. We end it. Right. Now when we go inside this Unity editor, you see when with the script, you see there's a center point over here, that is the game object we have to initialize, right? So we'll be taking the position of this object and we'll be rotating this object around this. So we will go into code. Now first, when the script starts to run, so what I have to do, I have to call the radius, right? So I have to initial I have already have the radius that I have initialized over here. What I'll do, I'll just go to the radius equals to transform, because I need to have that speed, right? I need to declare that speed. So for that, what I'll do, I'll just go to radius. I'll get that radius from the object, transform dot local scale dot x. Now you'll be thinking that what this local scale is, right? So what this is actually, you see there is a transform tool over here inside the inspector panel. You see this one, right? So in this, what we coded is transform dot local scale. We created what we did is we create call this transform function. In that we call the scale function, and in that we call the x variable. So whatever the x variable would be, as we know this all those things would be sphere, right? So we already know the scale of all these three things would be same, because we don't want any of the planets to be oval, right? So what we would be calling this scale x value over here, local scale, and what we would be dividing this by 2. Like we have to divide it into half, right? Because we have to rotate it from the center point. After that we declare the speed. Now what would be the speed of it, right? So for declaring the speed of it, we would be using something called as math function. See, in game development, mathematics is mainly important. All those things that we have thought, that the trigonometric function that we thought that we won't be using anywhere. We call a sine function or a cos function, sine, cos, theta, tan. There are many things. All those trigonometric function, we would be using all those stuffs in this, because in game development the mathematics is important, because nothing is in a game nothing is real. We Everything has to be simulated, so we need maths in that. So for that, in this speed, what we'll be doing is it will be 1, we'll be dividing it by what we will be doing it. We'll be using mathf function. Mathf is it's calling the math function from the libraries that we have already have inside the Unity engine, that we are already using the library. We will be calling the square root for it. SQRT is the square root for it, and then we click on radius and then close it. So now we have declared the radius and speed over here already, right? So now we need that to rotate around that object, so that comes under the update. Now what does the update function do is it updates the object every frame. Now as you all would be playing games, so you know when we play a game, in a game FPS is important. So FPS is nothing but a frame per second, so every frame needs to be updated. For example, if something is simulating, if the time is going by, then it should be getting updated frame by frame, right? So in the update function we would be transforming, we would be rotating into that. So what do we do in this? We write transform dot rotate around. We have to rotate it around the object. See, there are two functions in this. One is rotate and one is rotate around. What does the rotate do? The rotate function rotate the objects in at the same place, like it's rotating inside it, not revolving. We want to object it around, revolve something, so we have to write rotate around. So rotate around, we open the brackets. In that we have to call the object this center object, because we need to object to actually rotate it around the center dot. We need to call its position, right? So transform dot, we have to call its position, because we need to have that position in which what's the center point of it to rotate it around. Then comma, like in the transform rotate around, we declared 3 variables. The first, the x, y and z. For example, I'll just show you. X, y and z. This is the actual function that we would be carrying. So in this, what we did is we call the x position, that first point that we want to rotate it, right? So this is the transform. So x position is center dot transform dot position, and then what's the position? Second position would be vector. Now what is the vector, right? Vector 3 is the value of all these three. Vector 3 dot up, comma. Then we need to actually move it, right, in a specific speed. We have already declared speed, but if we haven't called a speed, so we call that speed. So speed multiplied by speed multiply. We have to increase the speed of it, right? And multiplied by been an issue lately. I guess the we are. No, I've adjusted all the settings. I'm sorry. Now we speed into speed multiply, and now we'll be indexing time. We need to update it every second, right? So we insert time dot delta time. Now why delta time is like we need to delta time is nothing, just the seconds of it. So we have completed our script, right? Now what will we do? We just close it. We'll go to the Unity engine. Onto the Mercury, we already have that script applied, right? What we'll do, we'll speed multiplied by 10. The center object would be sun, so grab that sun into the hierarchy and place it into the center. Now when you play it, we got a compiler issue, and you see there's a compiler issue over here. So we just delete this one. And we see transform, right? You see the compiler issue is over. We square root. I told you it's case sensitive, right? It's SQRT S capital. And when we go inside it and then we play it, so what happens that this Mercury starts revolving around the sun. Now we have already we have prototyped it, right? We have the object it for one object. We set it for one object. Now we'll be inserting different all the suns, like we have this all those planets over here, like Mercury, Venus, Earth, Mars, Jupiter, Saturn, right? So what we'll be doing, we'll be inserting all those objects. We'll be creating objects. Right click, game object, sphere. We'll be creating 0, 0, 0. Like if we have the 2, right? And now the there's a way now different type, like go to, every time we go to create, we go to sphere, right? So that's a whole lot of things. So we click on the object, we click on Control and D. So what does it does duplicate it. It's like how many planets are we having at this point? We are having approx 8 planets. So we'll be creating, we have already created 3 of them, like 4, and we will be creating more. We're just selecting 2 of the objects, Control D, guess we have to get one more, so we click on it. Yep. So now we'll be seeing this model sizes, right? So what this model size is, that according to the sun or the different planets, we would be having this type of ratio. So we can't take this ratio of the sun, right? Because 556.8 scaling is like too big. For example, I'll just show you, like, you see this 556, what is that, 556.8, like consider 556, right? 557 we consider, like, just click on just 556 by 556 by 556. See, it went away. Actually it didn't went away, it is here, but just it's so big that we can't see it. And when we insert this planet, just think of it, this are the planets, right? So when we actually drag the planets outside it, we even can't see the planets. So we need to see the planets, because as per the solar system, the sun is are the star. We need to see this solar planets. So what we'd be doing, we would be actually making this sun small. See, and now I'm not sure where my object is, right? It can be over here, it can be over here, it went away. So in that case, what you do, you just click on one of your objects and double click on it, and you just directly drag it in over there. We have this sun 1 as 1. Now in the next Mercury we are having 1.95. So we just go to Mercury 1.95. 1.95. After that, Venus we are having, so that is 484. This is Earth. Now we consider this is Venus. We rename it. There's a two way of renaming it. We rename it over from here, or we rename it from over here. So that's the Venus. We have this as 4.84. 4.84. And we'll have a perfect this kind of adjacent distance around it. We shift selected to select multiple objects, and then we have this Earth. Okay, not this Earth, our Earth, that we are facing some problems at this time, coronavirus and stuff. Don't worry, that will be solved. This 5.1. Okay, so as per the sizes that we are having, this are the stuff, right? Now after that, we are having Mars. So Mars sizes, we also have a moon, right? We need a moon. Around Earth we obviously need a moon, so we will be creating a moon. Now this we consider as Mars. Mars is 2.71, 2.71, right? Then we would be having our asteroid belts, right? So I'll be teaching you a way actually to how to create asteroid belts in this upcoming lectures, but I have already created a script that I have placed inside your folders. Here it is. So you get belt object and belt spawners. Just click and drag it inside this, and just keep it at this point. Like how you're gonna use it, I'm gonna teach you. This is then we have the asteroid belts. After that we would be having Jupiter, 55.93. Oh, that's a big planet. It's okay. We have Jupiter, then we have Saturn, the Saturn is 46.59, 46.59, 46.59, 46.59. We have issue here 46. Right. So we have here. We would be also be creating rings for the Saturn. Don't worry about it. And then we have Neptune and Pluto. We have this Saturn. We rename it. We'll just copy it and just drag it. It's not that big, but like it's okay. Neptune, we have the size of it as 19.7. So now we have all these planets, right? Now what we'll be doing, we'll be applying this textures onto it. It's easy, we just drag and drop. Okay, I think I have left one planet, that is the Uranus. Pluto, actually Uranus. So so the size of the Uranus is 20.29. Okay, go to 20, 20.29, 20.29, 20.29. Right. After this, what we do, we insert the textures into it. We already have added the Mercury texture. Now we'll be adding the Venus texture. Then we have the Moon. We have Mars. Then we have our own big boy Jupiter. Then Saturn. I think so. Yep, Saturn. Then Uranus. Then Neptune. Right. Now what we'll be doing, we'll be applying the script on all of this. We already applied on this Mercury, so we don't apply it on Mercury at this point. We select all of them, including the Jupiter and Saturn. We go to the scripts and we drag and drop the rotate script. And then in the game object, in the center point is Sun. When we play it, you see no object moves. This is reason for it. The reason is we have not mentioned this the speed of it. So we mentioned this the speed multiplied by 10. Like play. Now you see it started playing. So it's moving. But you see there's an issue over here that this moon is not rotating around the earth. The reason is it's not it's at this point its center is Sun, not the earth. So we have to change it. What do we do at that point is we go on the moon, we drag it and make it as a child of the earth. and then on the moon script we select the center as Earth. So when we do it, I would suggest that click on the moon and multiply its speed by 15. So like the moon rotates faster around the. So when we play it, you see the moon is rotating around the Earth, not the sun, and all other planets are rotating around the sun, right? Now we want to create this asteroid belt, right? So what do we do in that? I have already provided two of the scripts in the description, in the folder that you have downloaded. We click on this belt spawner option. We just click it, drag it, and drop it onto the sun. So you see this is some of the, there's a different cube prefabs and over here. So on this cube prefabs we'll be just placing the asteroid in one of the objects. We need to have this we need to what is cube density. See, a cube density is nothing, just the as per the script what that I have written, it's just basically the number of the asteroids inside the asteroid belts. So I would be using it to 2000. Now what is seed, right? Seed is nothing, there's a different orientation and all those stuffs inside this. So that is I consider it as a 50. The inner radius, see, basically the asteroid belt should be between the Mars and the Jupiter, somewhere over here, right? So it can't be from sun to the Jupiter, right? So we need to have this location. So this Mars is on the location 23.321 approx. So we think that we would be going from 27 to 40 or something like that, right? So we'd be click on sun, we click on the inner radius, we click on 27, and the outer radius we consider it as something around 35. The height of it, see, if I don't define the height of it, then what happens, every of the asteroid that is spawned in that area or in that circle, it would be in the same position, so it will overlap each other. So I'll just increase the height by 5. I'll just save it at this point, and when I play it, you see this is the asteroid, right? This asteroid would be appearing into the asteroid belts. There's an issue in this, let's solve it, no worries. We'll go to sun, we're rotating clockwise. Okay, so we go to sun, we drag and drop all the asteroids. We save it. Now you see the asteroids has came. You see, there's an issue that this is too near the Mars. So we don't need to do anything, we just need to adjust the position of it. We go to sun, we go to inner radius, and we position it as 30 or 32 maybe, and we reach till 40. We increase the cube density to 1000. So what happens when we play it, the number of asteroids that spawn will be more. So when we play it, you see the asteroid belts are more at this point. I guess we need more. So what we do is just go to the sun and we just increase all of these things. We don't have any issues. It's depending on your your preferences, that how many of the asteroids you want in that asteroid belt. So I'll just use some of my settings and just leave it, and just go 5, and just go 7, save, and go. Yeah, I guess that's pretty darn good. Okay, so we have this, and now we also have to have rings around Saturn, right? So we use the same script without any issue. So what we click on the Saturn belt spawner. Hmm? uh, we will be using the same asteroid, no worries. Or else we can do one thing, because the asteroids are very big over here, so we just click on the asteroid, we duplicate it. So we got the asteroid 1 over here. We click on the asteroid, we just drag it into the scene. You see how much big this is, how much this big is. So what we'll do, we'll just decrease the size of it. We'll be decreasing to 0.1 by 0.1 by 0.1. It's very small at this point, so it's not visible. No worries. We will just click on it and drag it outside over here. So what it will create a prefab over here. We will create as the original prefab. Then we can delete this. Right. We have already created. So in this Saturn, we focus on the Saturn. We have already placed this cube, right? So we just change this asteroid. We increase the tube density to approx 5000, because we need a ring, actual ring. We need a seed of 1000. Inner radius should be 0 and outer radius should be 5 or 10. I don't know at this point, so I'll just write 2. Rotating clockwise, I need this. Okay, so I'll just play it at this point. Okay, so when I go to this scene, you see I don't see any of this. I guess there is, but this they would be inside. Okay, so in this, I guess we have some issue. Okay, we don't have a mesh over here, so I'll just go to the mesh and select a mesh. Select, just play it, and then I would be able to see the rings around Saturn. This lagging because I guess there's a rings around Saturn, but they are not visible. Okay, so what do we do is we just delete this at this point. We go to asteroid 1, we go to Saturn, just drag and drop same things. Decrease this 5000 to 2000. We save it, we play it. There are rings over here, you see, it's inside at this point. The rings are inside because it's big at this point. So what we do is we create a inner radius as this 46.59, and outer radius we consider as a 46.59 plus 50. We create a 51. The height would be 2. Right, we save it and we play it at that one, and I guess we would be having the thing that we want, and that is the rings around Saturn. You see, but it is big at this point. We don't need this so big, right? So what do we do is we just go to the Saturn, we decrease the height of it. You see, we got, I guess, what we wanted, but it's not that near. So I'll just go to Saturn, I'll just take this 51 and drop it around 35 height, and I'll be increasing the cube density and just play it. And now I guess we'll be having this, the thing that we wanted, there's the rings around Saturn. It's not that pretty good, but we have this our own movement, right? You can just actually rotate it like this. You can just copy the rotation at this point, just place it. So when we actually do it, you will see there's a rings around the Saturn. The ring should be more big as per the norms. So I'll go to 35, I'll go to 40, I'll go to 40, I'll rotate it a bit more like this. Yeah, I guess this is perfect. I'll just play it, I'll just go to scene. This is pretty good. And at this point we are having what the simulation, the space simulation that we wanted, that this is a sun, Mercury, Venus, Earth, Moon rotating around its object Earth, Mars, the asteroid belts, the Jupiter, the Saturn, Uranus, Neptune, and they are all rotating as per their radius and speed. This is because in the rotate function what we did is we wrote the functions of it over here, that we divided the scale and we multiplied it by the time delta and transform position. This is because we have actually taken the radius of this sphere or the planet that we are taking, and we have arranged. So at this point, with that the simulation that you are seeing is actually the same simulation that is happening around in the universe, and that is just because of the mathematical functions that we have used. Now we have this, right? All those things we are having at this point. So what do we do at this point? How do I move around? See, there are two things inside this. That if you want to just deploy this, deploy in the sense we have to now we'll be also building it, right? So as of building it, now we want to build it for Android. So there's no issues for Android or iOS, because in the build function, you see there's a build settings. In the build function, you can build for PC, you can build for Android, you can build for some universal Windows platform, that's for Xbox or anything, for TV OS, for Apple TVs, PS4s, iOS, Xbox, WebGL, and there are many more inside this. I've not downloaded all of them because I don't use all of them, but there's iOS, Linux, and many things. So at this point we go for PC. So inside that's like I don't have when I play over here, I can just see it from here in the space. Like it looks pretty good, but I need some more attractiveness to this, right? So if this is fine for you, no issues. But if you want this to be more appealing, that you can watch it from anywhere, just take this script that I have provided in this script function, fly camera, take it, import it, and place it onto this main camera. I guess I might have applied into the places onto the main camera. See, it comes. So now whenever I move my mouse around, I can see the asteroid belts and stuff, right? I can just use WASD command to just go anywhere and just look from anywhere. You see how integrating its look. It's around actual asteroid belts, right? So this and this is for the Windows PC, because we won't be having the same functions in our Android devices. So at that point, what do we do is, like, first we'll be completing this PC stuff. So like, after inserting this script, go to file, build settings. In the PC, go to player settings, write the name of the company name or your name or anything. I'll just write my one, Realscape Simulations. I need to write the version. Like every game has a version, like 1.0, 2.0 something. This is my first bit, so I write 1.0. You can change the icon over here. You can just drag and drop a PNG and you can just drag it over here. You can just change it, the bullet identifier dot. You can even share it with your friends. So other settings. This is for PC, so we don't need to have any more thing inside this, right? You just I'll just cut it and I'll just build it, and I'll specify a folder. I'll like Windows. I'll just select the folder and it will start building it. It will freeze for a moment, but don't worry, it's gonna build it properly. After building it, you will be provided with this whole thing. Now you don't have to, whenever you are showing your simulation to someone, you don't want to take the whole your source file to them, right? So you just need take the game or the simulation over there. You just take this folder to them, or just send them over the email. You can just do it. You just create a space simulation. Yes, it says made with Unity. You see, I can just do all those things. You see, see, the main thing for building all this stuff, it's not an issue. For the main thing is, whenever you insert so much of asteroid belts, like in this scene, there are many of the asteroid belts. You see, there are like we can't even count it. Like there are many, right? Like consider like 1,000, 2,000, more than that actually. 1,000 plus 2, more than 20, 30,000. What happens at this stuff is, you see this. I'll just go to this. Go to this asteroid. You see, this asteroid has. You can see some squares over here. So that squares are basically the polygons. So for example, we'll just open this in a different software. Like I have a different software called 3ds Max. We'll go to Max. I'll just take I'll just go to this lecture content. I'll Asteroid FBX, just drag and drop onto it. Like why I'm doing this is to show you how much complexity this model is. You see, this asteroid is having more than 4,000 polygons. So just think of it, this 4,000 polygons, it's in just one asteroid, and there are more than 10 to 20,000 asteroids in your scene at this point. So might be possible some of your PC might get choppy at this. Like mine also is getting choppy a bit. So this choppiness is because the high level of the number of complexity that we are having. You see, this they are choppy at this point. Why? Because each of this asteroid is having 4,000 polygons, and you just multiply it by the number of polygons that by the number of asteroids that we are having. So the main thing of the game and all the stuff are, your game shouldn't be high in poly, your game or your game character, or it can be, see, you would be thinking that what is high poly and stuff is. The main thing is, if your model or your environment is very high in detail, like obviously everyone needs reality in game, but I'm talking about the high in placement details, like this modeling stuff. So at that moment the computer also renders that, even with the texture it even renders the model. So it takes the processing power very very much. So why you'd be thinking that why you need this all the stuff. Sorry. So you'd be thinking that why this complexity is actually important, right? So like some of your PC might be running GTA 5 on your PCs, right? It would be running smoothly, but some of you might won't be running smoothly. Why? The main reason is the complexity of the game, the high level, the high detail of the game. Like the PC should take that load power of that scene of that game to actually load that onto, or actually to process that all the environment onto your screen. If it doesn't process it, your games get choppy. That's the reason that you get a lag, right? Normally when you play a game you get a lag. So that lag is because of that complexity, that your PC isn't able to process that stuff, or the process that what we consider is as a model or anything. It can be the model, it can be the texture, it can be a sort of a script that includes some of the network issue, like in a multiplayer game. So that stuff increases the complexity of a game. So try to avoid this much complexity in your game whenever you are creating your games. But when see whenever you create triple A games, see there's a categories of games: single A game, double A game, and triple A games. Your PUBG, Fortnite, and many of the games, the high level games that we play, even GTA, Watch Dogs 2, all those games comes under triple A games, because those are high level games. Then and they're open world, open city, and you can explore many things inside this. And then that comes under double A games. What is double A game? Is basically the mission wise games that we play sometimes, that the old games used to come in. That I guess some of you have played Spider-Man 2, NFS Most Wanted, the old one I'm talking about, not the new one. The new one is considered to be triple A, the old one is double A. Then comes the single A games. Single A games are the simulator games, such as your PC building simulator, or we consider it as some, which one? There are many actually. PC building, the Sim simulator, which that we are having. Then there are many. We all the small Android games we consider as a single A game. Then a big 300 to 400 MB game that are high end textures and have a good gameplay comes under double A games. And PUBG, even for Android, the PUBG, the news that Fortnite is coming for phones, that is that all those comes under triple A games, because they are high level games. So there's a difference between triple A games, double A games, and single A games, and each of them have their own different complexity and the number of polygons in their specific scenes. That's the reason that some of you might not be able to run some of the games in your PC, because your processor and your RAM and your graphic card are not able to process that much stuff in a single moment of time, so that you can play that game. Might be possible it can meet the specific requirement, but it won't fulfill all the requirement, so the game would be laggy. You won't get your desired FPS in that game. Understood? So that happens in that. So at this point what I will be doing, I will go to the sun, because I know I don't need my Android application to crash, because Android phones don't have that complexity to actually run so much high polygons, unless and until you are using some of the Asus ROG gaming phones or stuff. Those are the on the different level phones, right? So we go to the sun, we go to the asteroid belt, we'll just increase it by 1000. Just play it and just see it. Does it look promising or does it not? It does look promising, so we don't have to do anything more. Like, so in Android we can't actually use this fly camera script. Why? because in Android the WASD function doesn't support in the sense it does support, but it should have the those buttons, those scripts, or those type of handles to actually move that stuff, like rotation and stuff. That I'll be teaching you that how to insert them even in the next lectures. Don't worry about that. But in this, the thing is, the first thing is, you need WASD function. So you don't have the WASD function, right? So what you will do, you'll just remove this script. You just untick it and you can just remove that script from there. What you will do, and then we click on the camera. We create F to focus it. We can also double click to focus it, but F is a good shortcut key for that because we have hands on keyboard. We create W. We go to this a bit up. We click on the camera. We transform it as per this. We rotate it a bit, and then we rotate it down. See, at this point you would be seeing that there is some sort of line in this in this skybox, right? That's because we are using this 6-sided skybox. If you'd be using this camera Milky Way skybox, then this would be looking something like this. Oh, sorry, I'm going to apply in this. You see, I'll just play it. And you see, this is what it looks like: the sun, the moon, and you just click on it. If we are building it for Android, like, so we just go to File, Build Setting. We click on Android. When we click on Android, we can't directly build it. We have to switch the platform for it. So we switch it. Just it will take a moment for switching it, and after switching it, we'll go to the player settings and change some of the settings over there. So it will re-import all the texture files and stuff and adjust it according to the Android file structure and Android supportability, because all Android doesn't support all the PNG files or all the type of textures files that we can say. So it imports all of the you can use all types of textures in the Unity editor, but whenever you are building for Android, the editor itself will re-import all the texture as the Android system, so you don't have to change any of the textures by yourself. So you don't have that we consider like a long work that we create different textures for everything. If you want to create a game for both PC as well as Android, we use the same texture files. We don't actually change the texture files. The same as in PUBG, right? In PUBG there are different maps. We consider the Erangel as a map, right? So the same map is in the PUBG, and the same map is in the PUBG Mobile, but the difference between that is the texture quality. In the texture quality in the PC is more high than that of in the Android. That's just the difference, because in Android so much high, so much detailed textures aren't supported. It is supported without any doubt, but when you try to actually run it, it will lag. It won't run. It might be possible it might crash. That's the reason you have to optimize that texture in low res for the Android stuff. But we are not doing at this stuff because the textures that we are having at this point in our scene is not that low high. So we just click on File. After all this, with Android, go to Player Settings. We have this icon. We can change this icon over here. So the splash screen, so we can have a splash screen of our own. You can see this preview, like this is how it comes. So we can have insert our own. What we do is just go to control, like go to our explorer, go to, drag any of the images. Like I'll just go to one of my images. I'll just drag one of it down inside my Unity editor. You see when it comes over here, the texture type is default, and you see that it's not a PNG file, so we can't actually place it onto this splash screen image. So what do we do is we click on default and we click on spread 2D and UI, then we click on apply. So after that, this you see this changes, the textures come in. So we click on this logo, we drag in this texture, we want it for stay for maybe 5 seconds, Unity logo below, and when we preview it, you see this logo comes in, and then this made in Unity come in. See, for now we'll be thinking that obviously I don't want anyone to know that my game is made in Unity, right? Obviously every game developer wants to keep his secrets to his own. But the main thing about Unity is whenever you are using the free version of Unity, you won't be allowed to remove that made with Unity function. Whenever you are using the pro mode, that whenever you buy it, then only you can use this check this out. You see, like, show Unity logo that is blanked out at this point. Why? Because I'm using the Unity free license at this point. I'll just player setting it. I set it the splash screen. You see in this publishing setting we have something over here. So this is things that we might need to consider when we are uploading it on the Play Stores, right? So whenever we are uploading this on the Play Store, we have to set this up. So I'll be doing a small lecture on this in the upcoming videos, that how to set this publishing settings for uploading over to the Google Play Store. I will be even covering how you upload your game onto the Play Store, right? After all these settings I have done, you click on build. You can just build a you see it creates a APK file over here. Then we give it a name like test, like first everything first is a test simulation, and we create a save, and then it runs it. It's build for it is building for the Android application. After this, you can just take this APK file into your mobile phone and just run it over there and see how does it look. You don't need to install any of the extra anything on extra Android apps from the Play Store. You just install this app and just run it. You don't have to do it. This is basically done when you are testing the application and stuff. So after this builds, okay. And you see after this APK is built, you can see how much MB of it is. It's just 36 MB. You don't have to you don't want your game or simulation to be too much, right? You see there's a difference between this Windows one and this Android one. You see the APK, the Android one is just 36 MB and the Windows one is 77 MB. The reason is this, because the Unity editor has optimized all the texture files for the Android and compressed them in a specific way, so it is stored in just 36 MB. And for Windows, it doesn't need to be actually compressed, because the Windows can support that much. That's the reason it has not compressed all these files. So after this, just take this file onto the Android device and just play it, run it. You don't have to be in issue. Just play it one more time. See, look how much beautiful that is. You can change the lights, and there are many things you can change it. So that's it for today, guys, and I hope you like the lecture, and I'm seriously sorry for the issues that in the starting that you have faced, for all the side menus and stuff you were not able to see. Like from next lectures, all those stuff would be taken care of, and please do share your videos or the APKs that you create watching this lecture, and if you have any of the doubts or anything regarding this lecture, just mail me, or just write it back in the comments back, and I'll be posting this video for future references onto my YouTube channel. So bye guys, thanks for today.